Hello again, everyone. We're still working on our bouncing ball code, and we're starting to look at classes. Classes are a tool that let you make a lot of the same kind of thing. They make you let what we call objects. Now, the best way to think about an object, it's a thing in the world, just like an object is in real life. So let's say, for example, I have, ooh, look, handy prop. I have this cup. This cup, of course, has a couple of things. It has a couple of properties. It has things like a position, and if I move it, ooh, it might also have a velocity. It might also have a color. It might also have a size. So these are things, these are properties that belong to this cup, this object in the world. But what if I considered all cups together? Well, then I might call those a class of object, a type of thing. Not a thing themselves, but a type of thing. Think about all cups. And so that's sort of the difference between a class and an object. An object is one thing specifically. A class is a type of thing. Now we're going to write a class definition. We're going to say, what does it mean to be a ball in our arcade sketch? What things does a ball have? What things can it do as well? So, first things first, let's get rid of all of that junk that we've been using before. Okay, so we can get rid of all of those variables up the front. We can get rid of this global stuff now. Classes are the solution to that global problem, needing to bring those variables in with that global keyword. We're not going to delete that the other stuff that you can see starting to be highlighted in yellow that my linter is starting to complain at me that's wrong. We're going to use that very soon. I am going to delete the second one because it's a duplicate. So bye-bye. Okay. Right. Let's make a class. So let's say, and how do we make a class in Python? We use the class keyword. And it's a ball. Classes are capital letter at the start. Capital first letter. Right here. Class, capital B for ball. And then some parentheses, colon at the end. Now, whenever we make a class, we get something for free. And that is an initialization function. It's called double underscore init. But we get that for free. Every time we make a class, that function is going to be run for us. But we have to change it. We have to make it unique to the class that we are using. In the Python background, it's just this empty thing which is waiting there, ready for us to define ourselves. So let's define it now. Double underscore init, and look. My IntelliSense is auto-suggesting it for me because that's what you do. You do this every time you make a class. First thing you do, define double underscore init double underscore. Okay. Right. Every time we define a function within a class, that's what we call a method. Every time we define a method of a class, we have to put in the word self. Okay? So self because it belongs to the class ball. It belongs to itself. What other things does our ball have? What does it mean to be a ball? What things can our ball have? Well, the things here that we deleted that we needed to pull in with global and define in the global scope and pull it into on draw. Those things. So it had an x, it had a y. It also had a velocity x and a velocity y. It also had a radius. And just so we can tell them apart, they also had a color. Great. Okay. What we need to do here is something that you find a bit strange the first time that you do it, but it starts to make sense when you really start understanding the idea of Python scope. These things will have all been passed into our init function when we make our particular object. But if we don't capture them, if we don't hold on to them, they're just gone. They're just going to disappear. So we need a way to capture these variables and store them within the class itself. Great. Okay, what do we have to do? I'll just do it, and you just follow along, and eventually it'll make sense because you'll have done it so many times that you go, oh, this is the thing we do. Why do we do it? And then you'll look into why, and then you'll understand. But for the moment, follow along with me. We're going self.x equals x. Self.y equals y. Self.velocity x equals x. Equals vel x. We keep going. Self dot. Velocity y equals y. Velocity y. Self dot radius equals radius. Self dot color. And again, we're just going to keep to American spelling. You could have used the proper spelling if you wanted to, but we're just going to keep to American spelling just for consistency. Self.color equals color. Great. Something to be aware of. Color and self.color are two different things. X and self.x are two different variables. They live in different places in memory, and you are assigning one value to the other. They are different things. All right? Okay. Great. Cool. The ball, each time we call a ball, it's now going to have properties. It's now going to have these variables stored together using this dot syntax, which is really, really nice. But we also want it to be able to do things. We also want it to be able to move, and we also want it to be able to appear on screen. So we're going to write two more methods, one called update, and another one called, normally I'd call it show. Let's call it draw today because that's sort of more arcadey. Let's call it draw. So we're going to go define update and self. Don't forget self. We're not going to pass anything else in. We don't need any other parameters here, any other arguments. Define update self. And what does it mean to update? Well, all of this stuff here. That's what it means. Cut that out and just pop it. And I'll try to show as much of this code as I can. Just pop it in here. Okay. Is that going to work like it is? No, it's not. Why not? A good friend, scope. These variables here are out of scope. Also, I didn't tab it enough. I didn't put it actually inside that method. There we go. Okay, each of these here, X doesn't exist anymore. X existed up here, but it doesn't exist down here. It's out of scope. As soon as this initialize function is run, poof, that's it. That variable X dies. It's deleted. It's gone forever. Poof, out of scope. Execution context. Disappear. Right. So how do we use it then? We do have something in scope that we can use that we assign to the same value when we ran that init function. So here it's self-dot. If you're working with classes, you will get used to self-dot. In fact, so much so that our good friend Coding Train has a lovely song. Of course, they use something different in JavaScript, but maybe we need a self-dot song going on here. Self-dot song. No, I won't copy everything he does, just most of the things that he does, because he's awesome, and he's a great source of inspiration. Daniel Schiffman, check him out. Very good coder. Okay, I'm just going to use that. Hold the Alt key, click, trick. Hold the Alt key and click trick. There we go. Click there, there, and 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 there. And all at once, in unison, self dot. And we're done. So we can now update. Now we can define a draw function, and it needs one argument, which is self, and what does it mean to draw? To draw a ball? Well, it means this. So copy that, paste it in there. Arcade.drawCircle field. That's what it means to draw a circle. Except, of course, self dot, everything is self dot, and here, self dot color. Nice. Great. We now have a class. A fully working, functioning class. Wonderful. It has an initialization method, an init function, or method, either or, take your pick. It has an update method. It also has a whole lot of properties that belong to it. Using that dot syntax, it has an update method so that it can update its velocity, it can bounce, it can you could accelerate it, you could change its size, you could change its color, anything. Do it in the update method if you're changing something about the object. It also has a draw method which tells Arcade how to draw that particular ball on the screen. Great. Okay, so is this going to work? What am I going to get if I hit run right now? Apart from some errors. Where are those two errors? I think missed some self dots. Always check your linter. They save you many, many minutes, hours, days of strife. If you have yellow squiggles, you need to fix it. Most of the time. Okay, what have we got? Come on, Arcade. Hit me. Show me, Arcade. You working? Or did I not close it last time? I don't think I closed it last time. That old trick. Here we go. It should be booting up again. Here we go. Okay. Nothing. Why not? Think of a class like a cookie cutter. You now have a stamp. You now have an exact mold. What does it mean to be a cookie? And a cutter that you can then take and stamp out as many cookies as you want. Bam, I've got a cookie. Bam, I've got another cookie. I've got another cookie. Bam, bam, bam. But before you actually have any cookies, you need to use it. We have just the cookie cutter. We haven't used it yet. Okay, let's use it. How do we use it? And that old trick, I ran it twice, so now it's gone. Wonderful. Yeah. We're going to make a new object. That object is going to have a name. It's going to be called... I'm not going to call it ball. I'm going to call it something like... I don't know. Soccer. Or hockey. Like a hockey ball. Hockey like that? Oh, hockey ball, right. It's going to and hockey is going to be the name of an object, and that object is going to be a ball. Look at this. Look what's popped up. How handy is this? Here are some things. Here are the things that I need to give this class, given to me by my IntelliSense, and they are, I need to give it an X, a Y, a velocity X, velocity Y, radius, and color, but you knew that already because you were there when we defined it. Whoa, can I have my mouse back? Thank you. Great, so let's give it those things. 200, 100, 4, 3. It's going to have a radius of 50 and a color of a tuple today, and I'm going to give it a tuple of full red. 25500, full red. Let's do it. Still nothing. Okay. We made it, but we're not actually showing it on the screen yet, are we? It exists in memory, but we didn't run that update function. We didn't run that show function either. So let's run that show function. Don't forget that we've made this here in memory down here, but we've actually got this arcade.schedule thing too. Don't forget about that, which is running the onDraw function. So actually when we want to draw something, we put it on the onDraw function. So that's where we're going to draw our ball. How do we get access to this method inside this class? Well, what we can say is hockey, which is the name of the object that we made, dot draw. Just like that, using that dot syntax. Wonderful. Hey, it's there. Excellent. Why aren't you moving? We ran the draw function, the draw method, but we didn't run the update. Okay, so on draw hockey dot update DATE hockey dot draw. Success! Wonderful! We now have a ball. It's got all of the same logic and the same attributes that we had before. You know, it's moving around the screen, it's bouncing off the edges, it's got a color. But that was an awful lot more stuff to remember, to think about. I don't want to have to think about classes and all. Why did you make me do that? Because it's a lot easier now to make another one. Let's make another one. Even though it's going to be circular, I'm still going to call it rugby ball, which is also going to be a ball, and it's going to have a position of 4 and 50, and its velocity is going to be 9 in the X and 10 in the Y. Whoa, it's going to have a radius of 30 and a color of arcade dot color, and I'm just doing this to remind you that you can do it 2 ways. It's going to be burgundy. Wonderful. No, maybe that's a little bit too red. Let's do something very different. What have you got under green? Generic Viridian? Ginger. Let's make it ginger. Might be an orangey sort of a color, I guess. Here we go. Again, forgot to show it, forgot to update it. Okay, so we do need to say, do this to both things. When you're drawing, make sure you draw both the hockey object and the rugby object, the hockey ball and the rugby ball. All right, so let's do it. Rugby.draw. Whoops. And rugby.update. DA did this last time as well. Boom, there we go. They are methods, so they do need the actual brackets after them to say run this. Hey, nice. We've got 2 balls. Awesome. That was a lot easier to make the second one. It was, you know, pretty complicated. There was a lot going on when we made the first one. But making the second one was absolutely easy. But I just don't want 2. I want 10. I want 100. And I promised that would be easy. It is. It is easy. There's a little bit more to it, but not much. How do we make lots of things? Well, let's let's leave those two. Yeah, let's delete those two. Bye bye you two, and bye bye hockey and rugby. Bye bye hockey and rugby dot update. Okay, so we want to make a lot of them. First of all, we need to store them somehow, and the best way to store them is in an array. So I've just shot up to the top of my code here, and I'm going to say balls is going to equal an empty array, and I'm going to come back down the bottom, and I'm going to say for I in range 10. I'm also just up the top. I just want to bring in random just for the moment, so I'm just going to import random, and nothing special, just a whole random module. Just bring it in. So for I in range 10, B is going to equal a new ball, and that's with a capital B, and it's going to have a random dot rand int 0 to width. As its x position, it's going to have random dot rand int 0 to height. As its y position, it's going to have random. I should have just imported rand int. Oh, I don't know why I imported the whole random module. Makes it a little bit longer. Random dot rand int 0. No, not 0. We're going to make it at least 1, all the way up to 10 as its x velocity. We're going to have exactly we're going to have exactly the same thing for its y. Now, you know what? I'm going to make this negative 10. Some of them are going to be moving in the opposite direction. And what else do we need? Radius. Needs a radius. I'm just going to make this look a little bit nicer. It's not going to change anything. Don't freak out. Just going to get each of these things and just hit enter after the comma so that it doesn't sprawl too far off the screen. This is something that makes your code a little bit more readable. And we're all about readability when we're writing Python. We need a radius. So it's random.randint, and radius is going to be somewhere between 10 at a minimum and 100 at a maximum. And color is going to be 3 numbers, each random.randint 0 to 255. And it's going to make a random color. Random red value, random green value, random blue value. It's going to look like hundreds and thousands in there. You know, it's going to be shaken about, but it's going to be great. It's going to be great. Let's do it. Color is a tuple. Random.randint 0 to 255. And I want a comma after here. So color is this 3 times, isn't it? That, and that. Yes. Okay. We've made the object. Each time this for loop goes around, we're going to make a new object with all of these random properties. Don't know what they are. Don't really care. They just make me a random ball with random properties. Thing is, I don't want them to be all the same because I want there to be different things. You see, they've all got their own independent x position, y position, velocity, color, radius, all of that. Okay, but we need to store them somewhere. We need to store them in that array. So balls.append b. Okay, we now have an array with 10 balls in it. And in fact, we can just go print balls, and you will see down the bottom, type int is not callable. Where is the error? Line 44 didn't have a comma at the end of line 44. There we go. So actually, I'll just get rid of that. There you go. You saw, here's an array. It's got square brackets on it, and you can count them up if you want, but we've got 10 ball objects. independent ball objects, and you see a little bit of, oh, you probably can't see that, but you'll see just a little bit of gunk here. Double underscore main dot ball object at. Okay, the thing that matters is this ball object. This at thing, that's what we call a pointer. This is getting off track. It doesn't matter. It's just where that object is stored in memory in the computer's brains. But you can forget about it. You don't need to think about it to understand what's going on. Just if you see it, don't freak out. Okay, let's get rid of that. And now let's say, on our onDraw function, we're going to say for b in balls, b dot update b dot draw. Just like that. Drum roll, please. Are we ready? Here we go. 10 random balls out there, all with random colors, random positions, velocities, and it was just like that. Okay, what do I have to change in my code in order to turn this from 10 to 20? Let's go braver. Let's go silly. Let's go from 10 to 100. How much code do I have to go and rewrite right now to change it from 10 balls to 100 balls? I think you might already suspect the answer. It's that. Let's see it working. Whoa! Look at that. Oh, I think we've got one stuck one down the bottom that has a velocity, 2 velocities of 0, but that's okay. We've got 100 colored balls all randomly moving around, and actually Python's kind of handling it okay. It's kind of okay. I think maybe it's my computer that's not handling it quite so okay, but you know, they're all moving around doing their thing. That's great. We have classes. That's the fundamentals of classes. You have a type of thing in the world, in this case a ball, and each instance, each specific ball itself, has its own properties and its own methods. And if you can call each of its methods using the dot syntax, you can set and you can access each of those properties using the dot syntax as well. And just to recap with the classes, when we defined it, when we actually made it here, when we actually made a ball, the first thing that was run was this initialization function. That was run automatically for us. That took all of that information that we passed in here, all of those random numbers that we didn't really decide ourselves and didn't really care about, all of those random numbers, and it saved them in new variables all grouped together for that specific object using self-dot. And then when we ran in this for loop, we went through each and every ball that we'd saved in that array. We ran b.update and updated that specific ball in that specific moment. And then we ran b.draw, and that's so for each of the things that was in that array, we ran its update method and its draw method, and its update method changed its X position and added and maybe checked if it was on the edge and changed its velocity if it needed to bounce. And the draw method said, hey, at these coordinates, draw a ball of this radius and this color on the screen, please, Python. And Python said, okay. And we had 100 moving, bouncing balls on the screen. Wonderful. That's a fair amount of code. I wonder if I can get it all on the screen just so you've got somewhere. I might zoom out a bit. Hopefully it's not too far that you can still see it in your window. Here it is. And hopefully I'm not in the way. That's all the code there. Wonderful. See you on the next one.